All right, let's check it out. 8.2, graphing inverse variations. An inverse variation is simply a relationship between two variables where if I multiply those two variables together, I always end up with the same constant. So if x goes really high, that means that my y is going to have to be really low to give me the constant, or if x goes really low, I'm going to multiply that by a really high y to give me the same constant. Okay, so inverse, if one variable is high, the other one has to be low, and vice versa. Okay, so example 1, suppose you drive 200 miles without stopping. The time it takes to travel a distance varies inversely as the rate at which you travel. So we're going to let x equal speed in miles per hour, and y is going to equal time in hours, and we're going to graph the variation. So when we break this up, as soon as we see the word inversely, we're thinking about this multiplication of two variables, okay, to give us this constant. Okay, so the constant in this case is going to be our 200, right? And x is going to be our speed, and y is going to be our time, right? And so it makes sense. If x, for example, is a lower number, okay, so I'm going 10 miles an hour, it's going to take me more time to cover that 200. But long story short, this 10 times 20 has to give me 200. At the other end of it, let's say I go a little bit faster and I'm going 50 miles an hour, okay? It's going to take me less time to get there, right? It's only going to take me 4 hours. So as my speeds increase, right, the time it takes me to travel my 200 miles an hour are going to decrease, okay? But every one of these combinations has to multiply out to give me that 200 miles, that constant of variation that's in this question. The way that's going to look is that as my speed gets bigger and bigger and bigger, my time is going to get smaller and smaller and smaller. The faster I go, the bigger number I get for speed, the lower number I'm going to have to use for time to maintain that constant of variation of 200. Okay, so in the context of this situation, the values we can use for speed and time are restricted, right? I know that speed has to be numbers that are greater than 0, and our times, I can't have negative times either, right? I don't know how to do a negative speed, and I don't have to know how to do a negative time. So our times also have to be, I'll just put this over here, have to be greater than 0 as well. So does this graph have an asymptote? Yes, it does. At x is equal to 0, we've got a vertical asymptote. And at y is equal to 0, I'll just put this one up here, we've got a horizontal asymptote. And why? Because if x, the speed, or y, the time, is equal to 0, then my equation, x times y, could never equal that distance of 200. So let's think about that. If x is equal to 0 here, there are no y's that I can plug in that are going to give me a distance, or no times that I could plug in that are going to have me equal a distance of 200. So I'm going to have a vertical asymptote at x is equal to 0. Likewise, if my y were to equal 0, or I guess we're talking about a time, right? If I travel for no time, then there is no speed along the x-axis here that can make my equation true. So that's going to give me a horizontal asymptote at y is equal to 0. Let's try and apply some of those ideas to a graphing example. So this is saying graph an inverse variation in which y varies inversely as x, and where y is equal to 3 and x is equal to 12. So the first thing we're going to do is we're going to just set up our equation. So I'd call this part here step 1. So because it says it's an inverse variation, we're looking for that multiplication of x times y, and we're going to use the point that they give us here to find our constant of variation. So 3 times 12 is equal to 36. So our equation ends up being x times y is equal to 36. Now, from there, does this graph have asymptotes? Again, yes they do. It has a vertical asymptote at x is equal to 0 and a horizontal asymptote at y is equal to 0, because if x or y equals 0, that means the equation x times y cannot equal 36. So same as our previous example in context. If x is equal to 0, somewhere in here, that means that there are no y's that I can multiply by that 0 to give me 36. So that's where our vertical asymptote is going to be. X is equal to 0 there. And if y is equal to 0, so here's the x is equal to 0. I guess that spot, it's actually right here, isn't it? X is equal to 0 is right there. That's my vertical asymptote. It's telling me my vertical asymptote is there, and when I put 0 in, I'm getting an undefined answer out, right? But here, I'm just going to erase this quick. But when my y is 0, wherever that's going to fit in, let's put that here, that means that my x would be undefined, okay? And that's going to give me my horizontal asymptote that goes right through there. And then all that's left for you to do after you've got that all set up, here, let me write that in there, y is equal to 0. Oops, sorry. Y is equal to 0 there, okay? And then all you're left to do after that is choose an equal amount of values on either side of the y-axis that fit the grid, and you need to make sure that they all multiply to our constant of variation 36. So 6 times 6, 36, 3 times 12, 36, 2 times 18, 36, and you just want an equal amount of points on either side of your x-axis, okay? So graphing becomes pretty easy if we just kind of follow those 3 steps. The first thing we're going to do is find our equation. So if it's telling me that I'm graph each variation if y varies inversely to x, again, I know that I've got that multiplication of x times y, and my constant of variation, they give me 1 point in here, negative 3 and 9. So when I multiply those two things together, I would get minus 27. Okay, so there's our equation. The next thing I would do is to go and find our asymptotes from our equation. So if x were to be 0, there would be absolutely no y's that I could use that would make my equation equal minus 27. So that's where my vertical asymptote is going to be. So my vertical asymptote is going to be the equation x is equal to 0. And my horizontal asymptote is going to be all of the places where if y is equal to 0, there are going to be absolutely no x values that make that equation true. So that means I've got a horizontal asymptote at y is equal to 0. So that kind of sets up a little skeleton for the rest of my graphs. So I'm going to split, kind of put my asymptote there, and when I go to choose my points now, it's kind of my third step is to choose some good points here. I'm going to choose points. Remember, they have to multiply to minus 27. So the two that I have there that they've given, minus 3 and 9, is one that works. Okay, I can actually I don't want to use that one so much there as I want to use it right here. And the reason for that I'll show you in a second. Okay, just real simple. What are two numbers that multiply to minus 27? Well, if I choose 1 for x, that means that minus 27 would give me 1 times minus 27 is 27. I could also use 3 and minus 9 here, so I'm just kind of working in this direction to graph those points. And I guess if I wanted to, I could use 27 and minus 1. So my positive x's that I chose there, 1 and minus 27 is going to put me here someplace. 3 and minus 9 is going to put me there. And 27 and 1 is going to put me there. So I've got 3 points, and I kind of just connect the dots. Make sure I put my arrows at the end, because I've got to show that that goes towards the asymptotes infinitely. And I've got that corner of my graph. Okay, let's do the other side, and I can just use the same x's except negative. So if I put negative 1 in, I guess I need 27 here to give me minus 27. And if I got minus 27 there, I guess I need plus 1. So let's go and graph those now. So at negative 1, I'm going to get plus 27. At negative 3, I'm going to get plus 9. And at negative 27, I'm going to get plus 1. Okay, and I've got 3 points there. I'm just going to connect the dots with a smooth curve and finish it off with my arrows at the end. So, equation, find asymptotes, and find points to graph so that those ordered pairs multiply to give you your constant of variation. You guys try example 2 and 3 now, push pause, and I'll come back with the answers. All right, bam, let's see how we did. Okay, the instruction above says that we're inversely related, so I've got x times y. I multiply the 4 and the 12 to get my constant of variation here, and each of these pairs that I made multiplied to 48, so that's good. I got my vertical asymptote and my horizontal asymptote set up here and here, labeled all nice, and my graph turns out to look like this weird thing, okay? In number 3, same deal. Find the inversely related, find the constant of variation, get some points that fit the graph, and ensure that each of these equals that constant of 162, and make sure that your graphs, after you plot the points, that your picture, not graphs, it's one graph, it's just got some places where there's break in the graph because of the asymptotes. Just make sure that they never cross those asymptotes. Let's move on to rational functions and excluded values. Shouldn't take too long. All right, so y is equal to 10 over x. So what is a rational function? It's when y is isolated and you see your independent variable x in the denominator in some form. Okay, so when we talk about excluded values, we're really finding the domain restriction for our function. So we know that when I see a fraction like this, my domain, my x, the one number it can never equal is 0. I can't have 0 in the denominator of my function. So let's just go ahead here. So it's trying to get the vocabulary right? So the excluded value and the domain of your function have things in common, but we just gotta kind of learn how to write them out and understand them. Okay, so for example, in letter A here, when I'm looking for my excluded value, I'm just saying, well, what makes the denominator 0? And in this case, 0 makes the denominator 0. So if I was to look at a quick little graph of what's going on here, okay, from what we were talking about before, if I take this x and multiply both sides by x, I've got this, don't I? So this is kind of an inverse variation question with a positive number here. I know I'm getting this picture. Okay, but more importantly, our excluded value is just where the vertical asymptote is. All right, so my excluded value is the place in the domain where I don't have any x. I've got graph everywhere, someplace above or below the x-axis, everywhere except for x is equal to 0. So that's an excluded value for this function. All right. It gets a little trickier when you get a little bit more complicated expression in the denominator. So also a rational function over here with b, okay? Except in this case, I've got a binomial, and so I want to find out, to get my excluded value, what's going to make the whole denominator equal 0. So what x is going to go into there that's going to make that whole denominator equal to 0? So I set up a little equation, x minus 5 is equal to 0, and I solve for x. And it's obvious, you can see it straight away, right? If I put 5 right here, 5 minus 5 is 0, I can't have that. I know that that is where, or that's what is making my excluded value. So just real quick, and this isn't something that we're probably going to get too carried away with right now, but this equation, what it means as far as the domain goes is that everywhere along the x-axis there is going to be graph except for where x is equal to 5. That excluded value is where the domain restriction and the vertical asymptote go. So this graph would end up looking something like that. So the excluded value is the number for x that I can't use with that particular function. So it's kind of telling me what the domain restriction is for that equation. So in letter A here, the excluded value is x is equal to 0. So the domain would be the set of all real numbers where x cannot equal 0. And over here, my excluded value, the x that I cannot use as an input for, an input for my function here, is going to be x is equal to 5, and my domain is going to be the set of all real numbers. Like I can put any x along the x-axis and get values out, except for x cannot equal 5. So super easy, right? Okay, so number 1, what's the excluded value? X is equal to 0. What's the excluded value in number 2? What number can go there that makes the whole denominator 0? You can make a little equation and solve for x. So the excluded value is x is equal to 4. Okay, and last but not least, remember, all you have to do is look at the denominator, right? You don't care what's in the numerator as far as excluded values go. So here you're going to set up an equation again. Say, what's my excluded where is that going to be? It's when that expression is going to equal 0. So x is going to turn out to be negative. Whoops, sorry about that. Is going to turn out to be negative 2 there. Let's move on to a word problem. Maya and her friends are eating at a restaurant. The total bill of $36 is split among X friends. The amount each person pays, Y, is given by y is equal to 36 over x, where x is the number of people. Graph the function. So let's just start making a little table here. X goes in, y goes out. So x is the number of people, y is how much the bill is given that many per person, given the many people, how many people are there. So if Maya is her only friend, she's going by herself to the restaurant, Maya is going to pay 36 bucks. If Maya goes with one friend, so there's two people sitting at the table, I need these to equal 36, right? Because as the number of people goes up, the bill per person is going to go down. The bill has cost $36, doesn't know how many people go. So this is really an inverse relation, right? It's kind of this one in backwards. So 2 goes in and 18 comes out. Let's do 1 or 2 more here. If 3 people go, that means that, well, 3 times 12 is 36. So 12 is 36. So the bill is going to be 12 bucks each per person. And well, here, let's do something crazy here and say if I got 6 people, Maya and 5 of her best friends go, that means the bill is only going to be 6 bucks a piece. Going with that many friends, if you still got 36 bucks, probably means that you're going to go on some sort of a diet. All right, so the model is going to look like this, just like we would expect it to. We realize that because the context of the situation means that the number of people has to be greater than 0, and the bill is definitely going to be greater than 0, that we've got those domain restrictions. And last question here, does this graph have an asymptote? 100% yes. You are not going to go to the restaurant and ever pay $0. So the question, or the answer to that question, is a big fat yes. And why? The bill will never be $0. That's it. That's a wrap. I hope that video does the trick for you. I'll try and do better next time, kids. Have a